Welcome back everyone. So in today's class we will look at IP address assignment. We will do this in the Cisco packet tracer. So we will do static and dynamic. First of all, we have to understand what IP address is, and most all of you know this as well. So IP address are digital addresses for your devices. So your devices will need IP address to communicate over the internet or within your local area network as well. So just like when you order, for example, Uber Eats, you'll need to give in your home address for the delivery to come to the right address. Just like that, IP addresses are addresses which are logical addresses for your devices. There are two ways you can assign IP addresses. So first one is static, which is manual, and then another one is dynamic, where you will use a protocol called DHCP, which is Dynamic Host Configuration Protocol. In static IP addressing, you assign the IP addresses to all the devices manually, like go to the computer and assign those IP address, whereas in dynamic, the new devices or devices connected to the network will get IP addresses automatically. Forgive my spelling over there. So we will do both of this in Cisco packet tracer, because our task is to learn about Cisco packet tracer. Let's go over to, for example, let's say, how do you assign IP address on your Windows computer? Easier way is, let's say, go to cPanel, click on Network and Internet, Network Sharing Center, click on the Ethernet connection details, properties, find IP version 4 over here, double click on this, and then use the following IP address. So that is what you do, and then you put in the IP address, subnet mask, default gateway, manually. It's easier when you have few devices, but when you have many devices, then it becomes very hard for the network administrator to keep up with this. That is when your DHCP comes into play. Let's look at in Cisco packet tracer as well. So the first thing I'm going to do is bring in a router, I'm going to bring in a switch, and I'm going to bring in two devices. Connect this like this, and then let's say our network is 192.168.10.0/24. I'm going to use the same network for DHCP as well, 192.168.10.0/24. Alright, the first thing you will do is, on this side we are doing static, on this side we are going to do dynamic. First, assign IP address to the router. For example, let's go to the router, let's do no over here, and then enable config terminal. What is our interface? You can see it in the screen. Interface F0/0, and then IP address is going to be 192.168.10.1 255.255.255.0, and then no shutdown is the command to turn it on. Now the light will turn green, and we have assigned IP address to the router. Now manual or static IP address for each of these computers can be done in Cisco packet tracer in this way. Click on the device, desktop, IP configuration, and 192.168.10.1 is already given to the router, so it has to start from 2, and then the default gateway is the router's IP address. Same thing on here. Before we do that, let's see if we can actually check the connectivity between these devices. So from PC 17 to router is successful. From router to the PC 18, it says PC 18 has no functional ports. That means there is no IP address on this computer. So we have to give IP address to computer. So another thing, every device will need IP address to be able to communicate on the internet. 2 is already given to that computer on the left, and the default gateway is router's IP address. Now let's check the connectivity from this computer to this computer. It says successful. But what happens when you have many devices? Yeah, again, smaller pool of devices can be assigned with static IP address, but as the number grows, then it will be very hard for the administrators to keep up with the need for IP address or IP address management. And that is where DHCP comes into play. Now let's go over to this page here. What is DHCP? DHCP stands for Dynamic Host Configuration Protocol. It is kind of your digital assistant that will assign IP address to any device that is connected to the network, which is automatically assigning the IP address. Yeah, but you have to make sure that you have a DHCP server somewhere. It can be a router or a dedicated DHCP server. In our example, we are going to make our router our DHCP server as well. So what do you have to know in DHCP is, in the background, as soon as your computer is connected to the network, 4 things happens. So that is the steps for DHCP, also called DORA, DHCP: discover, DHCP offer, DHCP request, and DHCP acknowledge. So you have a client computer here. Imagine this is your computer and you have a network. We have assigned our router to be our DHCP server. As soon as this device is connected to the network, the first thing it sends out is it broadcasts the message to discover the DHCP server. The first message is broadcast from client, and then the DHCP server will say, I have got this IP address, let's say 192.168.10.28. that is DHCP offer. It is coming from the server to the client computer. And next one, you will go to DHCP request. You will say, you will formally request that IP address. Okay, I want to use 192.168.10.28, and then the last step will be formally assigning that IP address to you, and that is DHCP acknowledge. So this is what is happening in the background. First, the computer will say, could someone give me an IP address? And then the DHCP server will say, okay, I've got this IP address, do you want this? And then from here it will say, the client will say, okay, I want to use this IP address. And then the server will say, okay, take it. And then your IP address is assigned. That is what happens in the background. We won't notice, we don't know what is happening in the background, but in the background this is actually what is happening. Now let's see how it is done in Cisco Packet Tracer. But before we do that, I want to show you a very simple process of creating DHCP server on, let's say, packet tracer. And I'm going to give you commands on this side, and I'm going to tell you what is happening here. The first step is you will create a pool. Or let's say this is a bucket, and you name this DHCP pool. So the first command is IP DHCP pool, and the name of the DHCP pool is DHCP pool. You have created a bucket, a pool. The name of the pool is going to be DHCP pool. Now you're going to say, all right, let's say this is our router. You're going to say that you're going to tell this pool that you're going to live in the router. We have to tell it, yeah? So the command is defaults router and then router's IP address. And then so that is step number 2 and command number 2. And last command would be you're going to tell this pool that you have 254. In our example, we are going to say we're using /24, so we're going to say that this tell this DHCP pool that it has 254 IP addresses available. Yeah, the command is going to be network and then the IP address and subnet mask. So there are 3 commands to create DHCP pool. First you create the pool, then you tell the pool that it is going to live in the router, and then you're going to say you have 254 IP addresses available. But ideally you have already assigned a static IP address to the router, because router is one of those devices that needs a static IP address that doesn't change. So you have already assigned one IP address to this, so you're going to exclude the router's IP address from this pool, so that when this pool assigns IP address to a new device, it will not assign the router's IP address. And then for testing or training purposes, sometimes you may want to reserve some IP addresses. Let's say a range, so from 5 to 10 IP addresses that you want to reserve. And then what you'll do is you'll exclude these IP addresses and the router's IP addresses from the pool. Yeah, so it's not exactly 254, it's 254 minus whatever IP addresses you are excluding, so that these IP addresses are never assigned to a device connected to the network. And the command is IP DHCP excluded IP address and then the IP address, so router's IP address, and then DHCP excluded IP address, range of IP address that you want to exclude. We'll look at this in the packet tracer now. So I'm going over to the packet tracer. Let's bring in a router. Let's bring in a switch. Let's bring in, let's say 1, 2, 3, 4, 5, 6, 7, 8 computers. Let's connect these to the switch. To the router, and this network is 192.168.10.0. so let's assign the IP address to the router first. You can do no here, enable config terminal. The router's interface is interface f0/0. IP address, we're going to assign the IP address 192.168.10.1 to 55.255.255.0 and then no shutdown. We have assigned IP address to the computer. Now instead of going to each computer and then giving IP address on here, we're going to use DHCP. So let's create the DHCP server now, and you know the process. First we'll create a pool, then with this command, and then we will say you're going to live in the router, and then we're going to say you have this many IP addresses through the network command, and then we will exclude a range and the router's IP address from the DHCP pool. So let's click on the router, exit from here, IP DHCP pool, DHCP pool. Alright, so that pool is created. We're going to tell it that it is going to live in default router, which is 192.168.10.1, and we're going to give it the network address, which is 192.168.10.0 255.255.255.0. that is it. We will exit from here, and then we'll exclude IP DHCP excluded address 192.168.10.1, which is router's IP address, and we're going to exclude IP address 192.168.10.5 to 192.168.10. let's say 10. That's it. So created a pool, tell it that it is going to live in the router. It has this many IP addresses. /24 means 254 IP addresses, but we have excluded router's IP address and the range. So let's look at this. Now let's go over to the computer, IP configuration. Instead of putting this manually, let's click on DHCP, and the DHCP is successful. Second computer, desktop IP configuration, DHCP, successful. So all of these computers will get IP address. I just want to show you what happens with the range that we excluded. So router is number 1, 2, 3, 4. Now we're going to number 5. Let's see what happens to 10.5. So the IP address jumped from 4 to 11 because we have excluded 5 to 10. Now IP addresses of the router and then the IP addresses of the range that we excluded will not be assigned to any other IP addresses. So you should be able to do it yourself as well. And if you have any question, you can just ask me, write the comment. I will definitely answer. So what did we learn today? We learned that IP addresses are unique identifiers of your device over the internet. There are two ways of assigning IP address: static and dynamic. Static is done when you have very small devices, or there are devices that will definitely need static IP addresses, like routers, servers, your DHCP server, network printers. All these kind of devices will need IP addresses because they cannot change every day. DHCP, when you are using DHCP, IP addresses are assigned to devices automatically, but when you get IP addresses using DHCP, the IP addresses are not assigned to you on a permanent basis. It is temporary basis. Yes, so if you have one IP address today, you may not have the same IP address tomorrow in the same network. So you can look at this one as well. Go to your Windows computer. Here just write CMD, and then let's do ipconfig /all. So in this VMware virtual machine, I'm getting IP addresses by DHCP, and then if you look here, the IP address was obtained today at 11/7, and it expires today at 12/22. So at 12/22, I may not get the same IP address because it is given to me as a lease. This is what happens when you are using DHCP server. And that will be the end of this demonstration. If you like this way, or if you like this video, you can hit the like and subscribe button for more tips on networking. So on this series, I'm trying to do everything in Cisco Packet Tracer, all the Packet Tracer labs that I find on the internet. So stay tuned, and then happy learning. Yeah. Cheers. Thank you.